Today we'll be talking about chapter 4.1 fundamental trig identity, and there are three parts for the formula. First is reciprocal. If we have sine of x, it should be equal to 1 over cosecant of x. According to this, if we have cosine, then we expect to have 1 over secant of x, because secant of x and cosine of x, they are inverse function. How about tangent? 1 over cotan x. Right. Second is the ratio. Okay, tan x equal to sine x over cosine x. Or if I want to write the sine in terms of cosine and cosine in terms of sine in terms of cosecant, the inverse function, and cosine x in terms of secant, then it will be flip secant x over cosecant x. And lastly, cotangent is equal to cotangent. Remember, it will be flip of tangent x. Then in this case, we will flip with cosine x over sine x. The last part is a Pythagorean identity. Okay, according to unit circle, we prove that sine square plus cosine square equal to 1, and there will be two more formula. Tangent square plus 1 equal to secant square. Lastly, 1 plus cotangent square x equal to cosecant square. Okay, let's try one of the example proof identity. Sine x times cotan x equal to cosine x. The way we mean proof, it means we have to set them equal to each other by playing around with the form. So the hint would be always convert everything in terms of sine theta and cosine theta, or in this case sine x or cosine of x, they're all always fine. So always convert everything in terms of sine and cosine. So sine, this is good. How about cotangent? Cotangent is not good, but because of the formula we just learned, cotangent, let me see, is equal to cosine over sine x. So we write in cosine x over sine x. Okay, what happened now is, you see, if they multiply sine x and sine x in the denominator, they cancel out. So at the end we have cosine x equal to cosine x, as long as you prove them equal to each other. Okay, again, for example number 2, we have cosine times tangent equal to sine. Remember, the hint is always convert everything in terms of cosine theta and sine theta. So cosine theta, this is good, but tangent we have to change to in terms of sine or cosine. And according to the ratio formula from above, is tangent equal to sine over cosine. And then that's equal to sine theta. And you see this later on, if these two multiply, sine will be the one only left, because cosine and cosine in the denominator cancel out. You have sine theta equal to sine theta, and we just prove it. Let's try example number 3. We have secant square theta times cotangent square theta equal to cosecant. Okay, first of all, do not get freaked out by this function, secant, cosecant. We don't use it a lot, but we can do it slowly by converting in terms of cosine or sine. Secant is 1 over cosine. And remember the square applies to outside. It's like 1 over cosine square. This multiply cotangent, and we just did about cotangent is equal to cosine theta over sine theta square. And cosecant what we learn is inverse of sine. So it's 1 over sine theta square. Oops, let me rewrite this. Now furthermore, we have to do this, then we have to distribute the square. 1 square is 1. Right here is cosine square. Here is also cosine square. Right here is sine square. In here is 1 square is 1. And then sine theta square is sine theta square. And now you have to simplify it. If this is fraction, top times top, bottom times bottom, you see that in the denominator cosine square and the numerator of the other term. And what's left is 1 over sine square equal to the left side is also 1 over sine square. And check, we just proved this identity. Oops, there's a theta here. Just messed up by erasing it. Example number 4. With secant square equal to cosecant square times tangent square. So first of all, secant is 1 over cosine square. Oops, just always remember that it's cosine theta. The theta will be always attached to the trig function. And cosecant is 1 over sine theta square. Tangent is sine theta over cosine theta and then square. If you can see this now, you have 1 square is 1, cosine square, and in here is 1 over cosine square theta. Note that if you put, it doesn't matter where you put your square. You can put it here or you can put it in the middle. They are the same. And multiply sine 2 squared theta over cosine square theta. And now you have two things. If this fraction multiplies sine theta square, sine theta square, they cancel out. We only have 1 over cosine square. This is equal to 1 over cosine square. So we just proved it. If you want, you can always convert back. 1 over cosine square is secant square. So as we saw, is secant square equal to secant square. Right now, example number 5, we have cosine theta multiplied by secant theta minus cosine theta equal to sine square theta. First of all, we know that we have to distribute it. Before we distribute it, convert everything in terms of cosine and sine. Secant theta is equal to 1 over cosine. And cosine, this is good. We leave it. Next is you have to multiply. Multiply means you have to do a distribution here. When we distribute, we have cosine theta over cosine theta, which is 1, right? In here is cosine square theta, because both of them cosine times cosine. This one stay with sine square. And this is 1. 1 over cosine square equal to sine square. So If you remember what we start off in the beginning, that the formula for the Pythagorean identity is right here. So if sine squared plus cosine squared equal to 1, so sine squared theta would be equal to 1 minus cosine squared theta. Oh, I use x here, so let me keep consistent with theta. And then if I look for cosine, then would be 1 subtract sine. So back to this. 1 minus cosine theta. It will be same thing according to the formula. This is sine squared theta. So sine squared theta, and just prove the trig identity here. And for the last one, I want to do it a little bit differently. If we assume we use a substitution x equal to cosine theta, and we have y equal to sine theta, then we save a lot of work when we write here. Tangent is equal to sine over cosine, right? Sine over cosine, what we have, sine. We, instead of using sine here, we use y over x. Sine over cosine, that's y over x. Multiply, how about cotangent? Cotangent, remember, is a flip of tangent, so it will be backward. And then plus, how about tangent? Repeating again, y over x. That's equal to secant. Secant is cosine, and secant is 1 over cosine, sorry, so it's 1 over x squared. The reason we use the substitution is just it saves a lot of work to write the trig function like tan, cosine. And now we have to distribute. We have here y times x, x times y. This simply is 0, right? X over x, y over y will be 0 later on. And y times y, y squared. X times x, x squared. Right here is 1 over x squared. In here, so it's 1 because yx over xy plus y over x squared equal to 1 over x squared. Okay, in this case, seems like they are not equal, right? But however, you're not wrong, because remember in the beginning we used this. So let's convert back to whatever the trig function we use. Y is sine theta, and we have square here. X is cosine. And this equal to 1 over cosine square. Okay, in order for this to add or subtract, we have to make sure the 1 convert to the LCD, right? We have the common denominator, so we will have cosine square here. Go to 1 over. Okay, just ignore the denominator right now. Look at the top. As that come from the Pythagorean identity. And yes, cosine square plus sine square is equal to 1 over 1. Or there's another way. Instead of crossing out this, in here is 1. For the second one, sine over cosine square is tangent square. This is secant. And according to the second formula, this will be equal to square here, secant. So we want to subtract 1 plus tangent theta. 1 plus tangent theta is right here, the second one. tan x squared plus 1 equal to secant x squared. So we apply the formula right here. It's equal to secant x squared, and secant x squared equals secant x squared.